Hello there, amazing students, amazing people, and all the lovers of chemistry out there. I am super excited to be here with you once again on this episode of Redox Reactions. It's been an interesting series so far, and today we want to look at how to balance redox reactions in basic medium. But right before we progress, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. If you're interested in the subject of chemistry, or there is anything about that concept you do not understand, please do well to subscribe to this channel. It has been made specifically to serve you to the best of my ability. So let's get into what we have for today. So basically, by way of introduction, it is important to know that balancing redox reactions in basic solutions is very similar to the acidic method. Now, we just did the acidic method in the previous video in this series, but there is one extra twist for the basic medium. Instead of leaving H plus ions or hydrogen ions in the equations, you will neutralize them using the hydroxyl ion. So I'm going to show you exactly how we'll carry that out, and then we'll move on into the concept of what we have for today. Now, there are steps to take when you want to balance a redox reaction in basic medium or in the basic medium. So here are the steps outlined. Now, all these steps that you can see on the screen right now from A to Z, they are the steps that you need to take when you want to balance a redox reaction in an acidic medium. So you take all these steps, you start by splitting the reaction into the two halves, the oxidation and the reduction. You balance all atoms except hydrogen and oxygen. Then you balance oxygen atoms using water, H2O molecules. Then you balance hydrogen using H plus ions. Then you balance charges using electrons, and then you make the electrons equal in both half reactions. When you do all of that, you add the half reactions together. Now, once you are done doing that, this is where you convert it to a basic medium. This is where the extra twist lies. Now, this is where you make the adjustment for the basic medium. What do I mean? After doing all of that, then for each hydrogen ion in the equation, add an equal number of hydroxyl ion to both sides to neutralize it. And wherever H plus and OH minus are on the same side, combine them to form H2. What we are simply saying is anywhere in an equation where you have H plus and OH minus on the same side, you combine them together to form H2O. So I'm going to show you exactly how we'll carry that out in solving some examples. And then finally, when you've done that, cancel out any water molecules that appear on both sides. For instance, if there's at your final equation, let's say you have A converting to B, and then on the left side you have one molecule of water, and then on the right side you have, let's say, two molecules of water. What they mean is that you're going to cancel out, or you're going to simply say 2 minus 1, since there are two molecules here and there is just one molecule here. So you say 2 minus 1, which will give you 1. So what you're going to have as the final answer will be A equal to B plus H2O. Now, don't get confused. We're going to do all of this one after the other. And the final check, you need to make sure that the atoms are balanced. You need to make sure that the charges are balanced as well. So without wasting time and without any further ado, let's get into what we have for today. So here is the first example. Balance this redox reaction in the basic medium. Let's get into it. All right, now, so the first thing we want to do, or the first rule when balancing a redox reaction in a basic medium, first rule says split it into the half reactions. So let's do that real quickly. For the first half, we have MnO4 minus yielding MnO2, and then we have I minus yielding IO3 minus. We've done that now. The next thing we want to do is to identify which part is the reduction half and which part is the oxidation half. So let's do that real quickly on the other side of the screen. Now we have for the first half MnO4 minus and then MnO2. On this side of the screen, let's find out the oxidation number of manganese. So we'll call it X since we don't know what it is, plus, if you remember, in the series of learning how to assign oxidation numbers to atoms and compounds, we were told that oxygen always has the oxidation number of -2 in compounds. And now we have 4 atoms of oxygen, which gives us -2 times 4. And the sum of all of these will be equal to the overall charge, which in this case is equal to -1. So therefore we have X plus -2 times 4 gives us -8. Everything equal to -1. And then we have X minus 8 equal to -1. Finally, we have X equal to -1 plus 8, which is equal to +7. So in this compound, the oxidation number of manganese here is +7. Now let's find out the oxidation number of manganese in this case here. So to find the oxidation number of manganese, we have X, which stands for the oxidation number of manganese, plus the oxidation number of oxygen here is -2, multiplied by the number of atoms of oxygen that we have, which is 2. Everything equal to 0. So in this case, we have X plus -2 times 2 gives us -4 is equal to 0. So we have X minus 4 equal to 0. And then finally, X is equal to +4. So what this tells us is that manganese has an oxidation number of +7 here and an oxidation number of +4 here. Now, when something goes from +7 to +4, we say that it has reduced. So therefore, that automatically means that this is our reduction half. So now let's calculate the oxidation number of iodine and see whether we'll get oxidation. So for the oxidation number of iodine, we have I minus giving us IO3 minus. Now in this case, the oxidation number of iodine here is -1 because of this overall charge here, which is a minus. So we have -1 as the charge here. Now, the oxidation number of iodine in this compound, we don't know. So let's call it X plus the oxidation number of oxygen in compounds is always -2 times how many atoms of oxygen do we have? 3. All of this will be equal to the overall charge, which in this case is -1. So we have X plus -2 times 3 gives us -6, which is equal to -1. So if we open up these parentheses or this bracket over here, we end up with -6. Then this is equal to -1. Taking this guy to the other side gives us -1 plus 6. So X therefore is equal to +5. So in this first instance, we have the oxidation number of iodine to be equal to -1. In the second instance, we have the oxidation number of iodine to be +5. Now, when something goes from -1 to +5, do we say it has increased or decreased? Of course, it has increased, which tells us that this is our oxidation half. So now we have identified our oxidation half and our reduction half. What is the next thing to do? The next thing to do, or the next rule says to balance all the atoms except hydrogen and oxygen. So let's do that very quickly. For our reduction half now, we have MnO4 minus giving us MnO2. So we're told to balance all atoms except hydrogen and oxygen. So the only element apart from hydrogen and oxygen we have in this equation is manganese. And you can see on both sides of the equation we have just one atom apiece. So manganese here is balanced. Manganese here is balanced. For the next equation, we have I minus giving us IO3 minus. The only atom here apart from oxygen and hydrogen is iodine. And in this case, iodine is also balanced because we have one atom of iodine on both sides of the equation. So that rule has been taken care of and it is balanced. Now the next rule says balance oxygen using H2O. Balance oxygen using H2O. So now for our reduction half, we have MnO4 minus giving us MnO2. Now, on this side, we have 4 atoms of oxygen, and on this side, we have 2 atoms of oxygen. If we want to balance using H2O, how many molecules of water do we need to add? Of course, we need to add 2 molecules of water so that we can have an extra 2 atoms of oxygen that will add to these 2 atoms of oxygen to balance with these 4 atoms of oxygen on the other side. For the other equation as well, we have I minus and then IO3 minus on the other side. How many atoms of oxygen do we need to add? Well, here we have 3 atoms of oxygen. So automatically we need to add 3 molecules of water to balance oxygen and make it 3 on both sides. So we've done that now. Next rule now says balance hydrogen using H plus ions. Balance hydrogen using H plus ions. So for the reduction half, we have MnO4 minus giving us MnO2 plus 2H2O. So now, how many atoms of hydrogen do we have? Over here, we have 2 times 2, which gives us 4 atoms of hydrogen. So automatically, we need to add 4 hydrogen ions on the other side to balance it. Did you see how that was done? Now, on this, for the oxidation half, we have I minus plus 3H2O, giving us IO3 minus. Now, how many atoms of hydrogen do we have? We have 6 because these 3 multiplied by these 2 gives us 6 atoms of hydrogen. So automatically that means we need to add 6 hydrogen ions to the other side. Are you seeing how all the steps are being taken? So at this junction now, our next step or the next step to take is to balance the charges using electrons or E minus. So let's do that very quickly. Now, when they say balance charges using electrons, for the first half, which is our reduction half, we have MnO4 minus plus 4H plus, giving us MnO2 plus 2H2O. So now let's calculate the charges on the left-hand side and on the right-hand side and see where we need to add electrons. On this left-hand side, you can see that there is a minus over here, which tells us that the charge in this compound is -1, plus there is also a charge over here, which is +1. And how many atoms own that charge? We have 4 atoms or 4 molecules of hydrogen ions. That becomes +1 times 4. So the total charge on the left side will become -1 plus 1 multiplied by 4 gives us 4. So the total charge becomes -1 plus 4, which is +3. On the other side, however, there are no charges. You can see there is no plus or minus anywhere. So the charge on the other side becomes 0. So therefore, we have +3 on the left side, and then we have 0 on the right side. Now, my question is, between +3 and 0, which one is greater? Of course, the charge +3 is greater. So that means we need to add 3 electrons or 3 E minus in order to make this side to be equal to this side. So putting that in the equation now gives us MnO4 minus plus 4H plus 3E minus, giving us MnO2 plus 2H2O. Did you see how we do that? So now let's do for the oxidation half. Let's do the same thing for the oxidation half and see what we'll come up with. Now, for the oxidation half, here is the equation that we have. We have I minus plus 3H2O, which gives us IO3 minus plus 6H plus. Now, when we are asked to balance charges, on this left-hand side, we're going to find out the total charges here, and on the right-hand side, we're also going to find out the total charges, and then we'll find out where to add the electrons. Now, on the left-hand side, you can see there is a minus here, which tells us that there is a charge of -1, and on this H2O, there are no charges, which is 0. -1 plus 0 gives us -1. So the overall charge on the left-hand side is -1. Now let's find out for the right-hand side. Over here, you can see there is a minus, which tells us that the charge is -1, plus. Over here, you can see there is a plus, which tells us that the charge is +1. How many atoms of hydrogen ions on this +1? We have 6, which is +1 multiplied by 6. So that tells us that this is equal to -1 plus 1 multiplied by 6 gives us 6. So we have -1 plus 6, which is equal to +5. So on the left hand side we have -1, and on the right hand side we have +5. So where are we going to add the electrons? Of course, we're going to add the electrons to the side with a greater positive charge. Now, how many electrons do we need to add to +5 to make it to be equal to -1? Of course, we need to add 6 electrons, or 6E minus. I'm sure you can see how this is playing out. So now, when we put it in the equation, or the oxidation half, the equation now becomes I minus plus 3H2O, giving us IO3 minus plus 6H plus 6 electrons, E minus. So you can see how that played out. Now the next thing to do, or the next rule to take in balancing a redox reaction in a basic medium, is to make the electrons equal in both halves. So now we have the oxidation half written over here. Let's write the reduction half right under it. So we have MnO4 minus plus 4H plus 3E minus, giving us MnO2 plus 2H2O. So now, in this equation, the one below, we have 3 electrons. Above, we have 6 electrons. How do we make 3 to be equal to 6? We just simply say 3 times 2 gives us 6. So what we do is to multiply this equation that is under, multiply it by 2, and then multiply this one by 1. So when we do that, what are we going to end up with? We'll end up with the first one remaining the same, I minus plus 3H2O, giving us IO3 minus plus 6H plus 6E minus. And then the one under becomes, since we're multiplying it by 2, it becomes 2MnO4 minus plus 8H plus 6E minus, giving us 2MnO2 plus 4H2O. I'm sure you can see how we got to this point. So now, all the electrons that are in both equations will cancel out each other. So these 6 electrons cancels out these 6 electrons. So the next rule says add the entire equation together. So let's do that very quickly. Now, when we add both equations together, what we're going to end up with is I minus plus 3H2O plus, because everything on the left hand side goes with everything on the left hand side in both equations. So we have 2MnO4 minus plus 8H plus. So we've added everything on the left hand side. Now let's come to the right hand side. On the right hand side we have IO3 minus plus 6H plus 2MnO2 plus 4H. So we've added both equations together, and this is what we have ended up with. At this point now, the next rule says for each hydrogen ion or each H plus in the equation, add an equal number of OH minus to both sides. Now, before we do that, let's do a little mathematics. You can see on this equation, we have 3 water molecules on the left hand side, and we have 4 water molecules on the right hand side. And you can also see we have 8 hydrogen ions on the left hand side and 6 hydrogen ions on the other side. So if we do a little mathematics, these 3, if we take it out from 4, it becomes 4 molecules of water minus 3 molecules of water. So that becomes, these 3 goes, now becomes I minus plus 2MnO4 minus plus 8H plus, giving us IO3 minus plus 6H plus 2MnO2 plus H2O, because 4H2O minus 3H2O, it's just H2O that is left. So now seeing this equation like this, are there any atoms that are similar to both sides? We have hydrogen ions here, and then we have hydrogen ions here. How many hydrogen ions do we have here? We have 6, and then over here we have 8. So if we do a little cancel out, it becomes 8 minus 6, which is equal to 2. So what we now end up having is I minus plus 2MnO4 minus plus 2H plus, after we did that cancel out. And then we have IO3 minus plus. Now this 6H has to go because we've minused it. So we have 2MnO2 plus H2O. Now, why did I do this cancelling out? So that our next step will not be too complicated. If I didn't do this step, we'll still arrive at our correct answer. But I did that so that our next step will not be complicated. Now, the next step says for each H plus in the equation, add an equal number of OH minus to both sides. Now, is there any H plus in this equation? Yes, we have 2H plus. So we're going to add an equal number of OH minus to both sides. So let's do that. So that gives us 2OH minus plus I minus plus 2MnO4 minus plus 2H plus, giving us IO3 minus plus 2MnO2 plus H2O. Remember, we'll also add 2OH minus to the other side. So we've done that now. The next rule now says wherever H plus and OH minus are on the same side, combine them to form water. So now, on this left hand side of the equation, you can see we have H plus and OH minus. So the rule says wherever we have H plus and OH minus, we'll combine them to form water. So let's do that very quickly. So adding 2OH minus plus 2H plus will give us 2 molecules of water. So now let's do that very quickly. We have 2 molecules of water, 2H2O plus I minus plus 2 MnO4 minus, giving us IO3 minus plus 2MnO2 plus H2O plus 2OH minus. Now, what does the next rule says? It says cancel out any water molecules that appear on both sides. Any water molecule that appears on both sides. So now let's check out. On this right hand side, we have one water molecule. On this left hand side, we have two water molecules. So what does that tell us? We need to cancel out. So if we cancel out, it becomes two water molecules, 2H2O minus one water molecule. So what will be left is just one water molecule. So after doing that, we end up with this final equation. H2O plus I minus plus 2MnO4 minus, giving us IO3 minus plus 2MnO2 plus 2OH minus. So this is our final balanced equation in basic medium. This is our final balanced equation in basic medium. If you check at this point, you find out that all the atoms are the same on both sides. For instance, for hydrogen now, H, on the left hand side there are two atoms of hydrogen here. On the right hand side, you'll see there are also two atoms of hydrogen. So hydrogen is balanced. For oxygen, you check, there is one atom of hydrogen here. Of oxygen, I beg your pardon, that is 1 plus, is plus 1 plus, there are 4 atoms of oxygen here, then multiplied by this coefficient of 2. That is 1 plus 8, because 2 times 4 will give us 8. So 1 plus 8. So there are 9 atoms of oxygen on the left hand side. How about the right hand side? On the right hand side, you can see there are 3 atoms of oxygen here, which is 3 plus, and over here there are 2 atoms of oxygen multiplied by this coefficient of 2, which is 4 plus, and then there are also 2 atoms of oxygen here, 3 plus 4 plus 2, which is equal to 9. So oxygen is also balanced. And then for iodine, there is 1 atom of iodine over here on the left hand side, and the same thing on the right hand side. So iodine is also balanced as well. And then for manganese, Mn, there are 2 atoms of manganese here and 2 atoms of manganese over here. Manganese is also balanced. So our final balanced equation in basic medium, H2O plus I minus plus 2MnO4 minus, giving us IO3 minus plus 2MnO2 plus 2OH minus. I'm sure you saw every step that we took. To arrive at this. So at this point, let's move on to the next question.